Hi, this is Mr. Manley, and I just want to take a look at a few problems that are going to require logarithms and possibly properties of logarithms. So in all of these we are going to solve for x, which means that we're isolating x, right? So if I take this first one here on the left, I'm going to say that I've got e to the x plus 2, and that's going to be equal to 22 over 5. Just doing a little addition property of equality and division property of equality there to isolate the x as much as I can. Now I've got this variable x, and if you don't have this set in your mind yet, you want to have set in your mind that when we're looking at a variable exponent, we're thinking possibly logarithm to solve. And what I would like to do here is use the property of logarithms. We could do it both. We could do it another way, but I'm going to use the property of logarithms. So I'm going to say log base e. Now, how do logarithms work? They say this base to what power is equal to this argument. So the power is x plus 2. And when did I say power? Over here I said power. So I'm going to put the x plus 2 over there. And the argument will be the 22 over 5. So this is really key, of course, if you've studied logarithms with me at all, you know that I think that this is very key to be able to make this conversion from a to the b is equal to c. And if this is true, so if a to the b is equal to c, then the other statement that we can make is that the log base a of c is equal to b. And this is absolutely critical to our work with logarithms. I believe if you understand this, you can do anything that you need to with logarithms. So back to the question at hand. First of all, we're not going to say log base e, right? So hopefully you know that, and you were thinking, when is he going to change that? So we're going to change that now, and that was log base e, and of course we're going to write that as ln. ln is log base e. And to solve for x, I simply isolate it, and I've got ln of 22 over 5 minus 2. And there's not anything that I really want to do with that as far as solving it, or as far as expressing it in a different form. So let's move on to the other side here, on the right side. And we're going to isolate here. I guess I could have looked ahead and done that a little. Do another step here. Okay, don't be thinking of dividing by 3 here. There's nothing we can do because of the order of operations. So we're going to apply the properties of logarithms. I'm going to show you a different way here. Actually, I meant to say we're going to apply the definition of logarithms. But I'm going to show you something else here. I'm going to use a property of equality. So I can log both sides. And what's more, I can log both sides and use whatever base I choose. So I just said I'm going to take log base 3 of both sides of the equation. That's a property of equality. Going all the way back to the addition property of equality, and then we can square both sides. Can take the square root of both sides. I'm doing a log of both sides. Now look what happens on the left side here. X. Okay, so I use the power property of logarithms, which you should know. And now I've got log base 3 of 3. Well, please know that. 3 to what power is equal to 3? 1. So that's x times 1, and log base 3 of 6. All right, so I just used I could have done that method over here. I could have taken a natural log of both sides. Would have worked out the same way. And on this side, I could have used the definition of a logarithm the way I did on the first problem. So there's two methods, and you can choose which one seems to be whichever one you want to use in any given case. Okay, so that was solving exponential equations here. Okay, and now I'm going to look at solving log equations. This first one is simply applying the one-to-one property. So the one-to-one property says that if I've got the log of something equal to the log of something, those two somethings have to be equal. So I'm going to be able to say here that rad x plus 2 is equal to x. I used the one-to-one property. 1 to 1. I did not use a property of equality. I did not divide by ln. I did not do this. Why not? Because logs are not numbers. We do not divide by numbers, or this is not a number that we can divide by. Log is an operation, and we can't divide by an operation. So although it would get you to the same place if you thought about it incorrectly, I want you to think about it correctly. So here is rad x plus 2 is equal to x. Square both sides. And we'll isolate and set equal to 0. And can we factor this? I think so. X plus 1, x minus 2. And we get x equals negative 1 or x equals 2. And I'm glad this came up because look at this. You see x equals negative 1, and let's think about if I substituted negative 1 for x. It'd be undefined, right? Because we'd be saying e to what power is equal to negative 1. And there's no power that I can raise e to that will give me negative 1. So we're going to reject that solution and say that our solution is x equals 2. Okay, on the right side here, let's see what we've got. I'm going to use division, the quotient property, to combine these into a single expression, a single log expression. And then we are going to use the definition of a logarithm. So this is base 10, right? It's an understood base 10. 10 to what power? Well, it says to the first power in this case. 10 to the first power is equal to this argument. So using the properties of logarithms, I can say that x over x minus 3 is equal to 10. And that goes back to what I'd written before. I think I wrote that over here, where I talked about, maybe it was in a previous video, maybe it was this video, that a to the b, if a to the b is equal to c, then log base a of c is equal to b. So we've got to be able to make that transition, use that definition of a logarithm. Okay, let's finish solving here. I've got 10x minus 30 is equal to x. And then 9x is equal to 30. And x is equal to 30 over 9, which is 10 over 3. And that's it. I may take a quick look and make sure that that's in the domain up here, and that it's not a solution that I need to reject. Just because there's only one solution doesn't mean that I don't need to check it. So there we have solving equations, using logarithms, properties of logarithms, definition of a logarithm, one-to-one property, and you can take a look at those and hopefully be able to do some of these exercises.